In Swift, the self keyword has a special and important purpose, but it comes in two variations: self with capital S and self with lowercase s. Although it's the same word, these two self variations have actually significant differences, which I will try to highlight in this video through simple code examples. In a nutshell, self with capital S refers to a type, such as a class, struct, or enum. In contrast, self with lowercase s refers to the actual instance of a type, and it's used in initializers, methods, and closures. We'll see all that in more details, and to get started, let's focus first on self with capital S. Let's consider a basic example involving a protocol and two types that conform to it. More precisely, suppose we have a protocol named duplicatable, with one requirement. Any conforming type must implement the duplicate method and return a new instance of the same type. To see that, let's define two custom types that conform to duplicatable, with the first one being the point struct. The other is the rectangle type. See that in both point and rectangle, the duplicate method returns a new instance of its own type. For point, it returns a new point, and for rectangle, a new rectangle. By seeing this, we could tell that self is a type placeholder for the conforming type. It's not a specific type, but rather a stand-in for whatever type will conform to the protocol. But besides placeholder, self ensures type consistency. With it, it's certain that any type that adopts duplicatable and implements the duplicate method returns an instance of its own type. This also guarantees safety, as it makes it impossible to return a different type from the duplicate method. Let's pass now to a different example. This time, let's create another protocol named JSON representable, which requires conforming types to be both codable and provide a method for generating a JSON representation of themselves. Here, where self-codable ensures that any type conforming to JSON representable must also conform to the codable protocol. For example, here is the implementation of two types that adopt JSON representable. The first is the user struct. The other is the product struct. In both user and product, the JSON representation method leverages their codable conformance to encode themselves into JSON format. The role of the where self-codable clause in JSON representable is quite particular, because it introduces a restriction ensuring that only types that are codable can conform to this protocol. This is useful because the primary functionality of this protocol, generating a JSON representation, requires encoding capabilities provided by codable. This constraint declares a specific requirement of the protocol which the compiler will enforce, but it's also a sort of a guide for the developers. In addition, this example over here demonstrates protocol-oriented design. Protocols can define not just the methods and properties that conforming types must provide, but also the underlying requirements those types must meet. And the most interesting part here is that self is a key player to managing that. Although the use of self with capital S does not stop here, the previous two examples are good enough to demonstrate two strong use cases and how self works. Let's change page now, and this time let's focus on self with lowercase s. The first occurrence where we often meet self is in class or struct initializers. In such cases, it's used to distinguish between instance properties and initializer parameters when they have the same name. For example, see the person class. The two parameters in the initializer, name and age, have identical names to the two instance properties of the class. To avoid ambiguities and errors, we access both name and age properties with the self keyword. In this line of code, self.name refers to the property, while name to the parameter. Similarly, self with lowercase s is also used in methods when it's necessary to differentiate the property from the parameter. The updateDetails method demonstrates that. Another common use of self is in closures, where it's necessary to refer to the instance of the class or struct where the closure is defined. See the task manager class and more particularly the addTask method. It calls the perform task, which takes as argument a closure. In the closure's body that's called when the task has been performed, we append the task parameter value to the tasks array, which is an instance property. To access it within the closure, it's necessary to use self, which in this case is captured weakly to avoid retain cycles and memory issues. Besides classes and structs, self is also used in enums, and especially in methods that we define in them. In enums, self can be used to refer to the current case of the enum, and that's why it's often seen in switch statements. Consider the traffic light enum that represents the 3 traffic light options. To indicate the next color of any case, we can implement a simple method where we determine the current traffic light color and then return the next one. Self refers to the current value that an instance of the enum has, and it's often in pair with a switch statement, without, however, this being a rule. There is one last point I would like to focus on, and that is the self key path we often see and use in SwiftUI. A key path in Swift is a way to reference properties of a type in a type-safe manner. The self key path is a special key path that refers to the entire instance of a type. In this pretty simple SwiftUI view implementation, for each iterates over the numbers array and prints its number in a text view. Using id self, each integer in the array is used as its own identifier, because integers are unique. We can use the self key path in custom types, even though it's strongly recommended to make them conform to identifiable protocol and have an ID property. If, nevertheless, you want to use self to uniquely identify each instance of a custom type, make sure that your type conforms to hashable protocol. So, that's all about the self keyword in Swift. Remember that self with capital S refers to a type, while self with lowercase s refers to an instance of a type, allowing to explicitly access its properties and methods whenever that's necessary. I hope you enjoyed this video and you've learned something new here. If so, don't forget to like it and also subscribe to my channel so you don't miss any new videos. Your comments are much appreciated as well. Thanks for watching and take care.